for number 7, I'm going to show you a little bit more of the answer key to this one. But I want to focus first on just being able to interpret a chi-squared test. Basically, if you know the significance level or the critical value, you can run a chi-squared calculation very quick and know the results to the test very quickly. So in this case, if you've read through the information, what you want to notice is the information we're given is the 5% significance level, and there's other important things here, but here's what we know. We reject the null hypothesis if chi-squared calculation, right? So if our calculation is greater than the critical value, or our p-value is less than the significance level. Well, out of those two statements, in order to know if I'm going to reject the null hypothesis, I know the significance level, and it is 5%. So that means if our p-value is less than 0.05, I am going to reject the null hypothesis in favor of the alternative. So if I were to run a chi-squared test right now, which I'm going to do, I would be able to state the result of this test very quick. And so let's go through the motions there. And let's go ahead and run this chi-squared test, and then I'll run through the key for this question. So just remember keystrokes here. So you're going to hit second and then matrix. That's the fourth button down, third one down under the second button. And then go over to edit. And then you need to enter a matrix that matches the observed table given. So we have two rows, the male and female, and then 3 columns. So I need a 2 by 3. And here's the deal. If you mess that up, if you did a 3 by 2, it doesn't quite look like the table I'm given. So that means I need to switch those numbers around, right? So 2 by 3, and then enter my data. So 39, 16, 8, 21, 14, 17. So at this point, I can run my chi-squared test. I can go to stat, I go test. I like to scroll up to option C, chi-squared test. Matrix A is what I put my data into. Matrix B is where my expected values will go. And then calculate. And there it is, right? So we have our critical value, our calculation now, our chi-squared calculation, but we don't need that in order to make our conclusion. We can base our conclusion off of our p-value. So that p-value, excuse me. So let me bring up my screen here. So that p-value is 0.0203 to 3 sig figs, 0.0203. And the question is that less than 0.05? So 0.0203 is less than 0.05. So we are rejecting the null hypothesis if my p-value is less than the significance level. So if we reject, that means we are going in favor of the alternative. So we know at the end of this, we should be concluding that we're accepting the alternative hypothesis. So we reject the null hypothesis if our p-value is less than the significance level. So at this point, I know the answer to this question, but I'm going to go through and show you the answer key to this question. And it requires you to do all the steps. So all the steps of a chi-squared test to get full credit. So what I want to show you is a mark scheme, and we've seen these before, but you'll start to see these a lot next week because we're going to grade our apps. So let's go through the mark scheme here. Notice the expected table, right? So part A requires you to have the expected table. So that was the first thing. Okay, so these 6 cells would be the expected values. Just remember that is the row total times the column total divided by the table total to get each of those values. Or if you run the chi-square test, I could have gone back and looked in that matrix and found those expected values. We've got our null hypothesis and our alternative. Remember, independent versus not independent. As long as you get your wording across, it's those two keywords that are important. Degree of freedom, you need to make sure you show that. Row minus 1 times column minus 1, or vice versa. And then in this case 2. We verified that with our chi-squared test as well. These 3 marks right here. So notice these 3 marks, you do not need to use the formula. We use our graphing calculator to do this. So we can write down the critical or the calculation, right? So that is helpful, that is important to write down and to know what that is. But in this case, we didn't actually use it to interpret, right? So these 3 marks, really, we can call those G3. We use our graphing calculator. We have the critical value, right? You could have used your table from your notes and looked it up. That's never going to be required from you on an exam. So what is required is you either, when you're given this value, you have to be able to interpret, or if you, again, can use the p-value to interpret with the significance level, that is the other method we need to be able to do. So that is what we had done, right? So we had said, in this case, they show the calculation they got is greater than the critical value, right? So 7.77 is greater than 5.99. So we do reject. So that means what we want to say as our final answer is the choice of game is not independent. That is the alternative, right? That is the alternative hypothesis that we stated. We had come to that conclusion by saying our p-value was less than the significance level. And that should tell us the same thing. Okay, so there's 13 marks alone in part A. In part B, if this chi-square test were applied to a new set of data, why would it be necessary to combine billiards with another game? The issue comes down to expected values. If you get expected values less than 5, that's an issue. And we'll talk more about that later, but that's the main point of that question right there. Which other game would you likely combine it with? That's really kind of opinion. Billiards and snooker are similar games, or if you said billiards and darts, because darts had the next least amount of people, either way, right? Part C, you're just looking at probability, right? So probability that female who choose billiards or snooker and male or female who choose darts or fencing. You can work out those probability questions. I'm going to show you the mark scheme anyway, right? So there's B, part 1 and 2, the mark scheme. And then, C, part 1 and 2 is also there. Okay, so you should have number 7 fully correct by the time you get through this video. If you go back and correct it. So when you grade it, there should be full 17 points, right? That whole question was 17 marks.